Welcome to RenEnergy.com, your renewable energy and sustainability platform. In the grand theater of technological innovation, one sector is seizing the spotlight with groundbreaking developments: aviation. As the world contends with the escalating climate crisis, the push for sustainable solutions becomes all the more urgent, transforming the way industries operate. For the aviation industry, this translates to a Herculean task: the pursuit of eco-friendly aviation. Amid numerous solutions being proposed and explored, one stands out: the possibility of hydrogen-powered aircraft. But are they indeed set to dominate the skies of the future? Let's embark on a deep dive into this fascinating concept. Hydrogen-powered aircraft, the concept. Hydrogen-powered aircraft, as the name suggests, are airplanes that utilize hydrogen as their source of power. They do this either through burning hydrogen in a jet engine, in a similar vein to traditional aircraft, or by utilizing hydrogen to power a fuel cell, which in turn generates electricity for an electric motor. McKinsey & Company suggests that hydrogen aircraft could start making a significant impact on the market from the late 2030s and potentially account for about 1/3 of the aviation industry's energy demand by 2050. Hydrogen, when harnessed from low-carbon sources, has the potential to create zero-emission flights, dramatically lowering aviation's environmental impact. The idea has gained traction with industry giants, as both Boeing and Airbus have indicated interest, with Airbus pledging to have a commercial hydrogen-powered aircraft ready by 2035. Yet, this fascinating prospect is not without its challenges. The primary one being the storage of hydrogen fuel. Given its low energy density, hydrogen demands specially designed tanks, unable to fit in traditional wet wings of aircraft. This requirement could impact the overall design, weight, and balance of the airplane, all crucial elements to aeronautical engineering. Hydrogen's properties and their implication on aircraft design. Hydrogen's properties present a unique conundrum in the realm of aviation. Hydrogen has a specific energy nearly 3 times higher than that of conventional jet fuel. This means it can produce significantly more energy for a given weight. However, its energy density, the amount of energy per unit volume, is 3,114 times lower than jet fuel. In simpler terms, hydrogen fuel takes up more space, even when stored under pressure or in a liquefied state. Consequently, designing aircraft that can effectively store and utilize hydrogen fuel poses significant engineering challenges. Overcoming this necessitates the use of cylindrical fuel tanks, a design optimal for minimal thermal insulation weight. Given hydrogen's properties, these tanks would need to be placed in the aircraft's fuselage, drastically altering the design blueprint. This larger fuselage could increase aerodynamic drag, add extra weight to the aircraft, and potentially cause variations in weight balance during flight, each of which presents unique engineering challenges to be addressed. The environmental impact of hydrogen-powered aircraft. When it comes to emissions, hydrogen-powered aircraft employing fuel cell designs are zero-emission during operation. Hydrogen combustion does result in the production of nitrogen oxides, NOx, but it produces up to 90% less NOx than kerosene-based jet fuel and completely eliminates the formation of particulate matter. These factors contribute to a significant reduction in harmful emissions compared to the conventional jet fuel used today. The feasibility of hydrogen-powered aircraft hinges on the successful production of hydrogen fuel. Currently, most of the world's hydrogen is produced using natural gas, a process that emits substantial carbon dioxide. However, there are alternative, greener methods, such as electrolysis, which splits water into hydrogen and oxygen using electricity, preferably from renewable sources. This would make the production of hydrogen virtually emission-free, bringing us closer to realizing the dream of green aviation. In addition to clean fuel production, the infrastructure necessary to support a fleet of hydrogen-powered aircraft will need to be sustainable. This includes not just the airports and the refueling infrastructure but the entire supply chain that produces and delivers hydrogen to aircraft. These are significant changes that will require a significant investment of time, money, and resources. Economic feasibility of hydrogen-powered aircraft. From an economic perspective, the introduction of hydrogen-powered aircraft poses both challenges and opportunities. To begin with, the initial investment required to develop, produce, and introduce these aircraft into commercial service is likely to be substantial. The development of the necessary supporting infrastructure, such as refueling stations and maintenance facilities, adds to the costs. On the flip side, operational costs of hydrogen-powered aircraft may be lower compared to conventional jet fuel aircraft due to potentially reduced fuel costs and improved efficiency. The total cost of ownership could become competitive as the industry scales and matures, leading to lower costs for both airlines and passengers. Additionally, governments around the world are already offering significant financial incentives for the development and deployment of hydrogen technologies. This financial support could offset some of the initial costs associated with hydrogen aviation, making it a more attractive proposition. Implications on the aviation industry. The adoption of hydrogen as a primary aviation fuel could transform the industry. From aircraft design to infrastructure, training, and regulations, all aspects would require a significant overhaul. Aircraft manufacturers would need to invest heavily in research and development to design and build aircraft suitable for hydrogen propulsion. They would need to work closely with regulatory authorities to ensure these new designs meet stringent safety standards. Airlines would need to adopt new operating procedures and maintenance practices, as well as retrain their staff. They would need to work with airports to ensure the necessary infrastructure is in place for hydrogen refueling. Regulators would need to review and possibly revise current regulations to accommodate the use of hydrogen as an aviation fuel. They would need to develop new safety standards, inspection procedures, and certification processes. Airports would need to invest in new infrastructure to store and deliver hydrogen fuel. They would need to develop new safety procedures for handling hydrogen, which is more volatile than conventional jet fuel. The potential future of aviation. As we explore the concept of hydrogen-powered aircraft, it's clear that it's a captivating and feasible solution to the sustainability challenge facing the aviation industry. Hydrogen's potential to cut emissions to near zero makes it an enticing prospect for the future. However, the realization of this potential is conditional upon overcoming significant challenges. Not only does the design and operation of aircraft need to be revamped, but so does the entire hydrogen supply chain. The undertaking requires large-scale collaboration between governments, the aviation industry, fuel producers, and technology providers. It's indeed a daunting task, but the stakes have never been higher. With climate change threatening our planet's future, the time is ripe for bold, innovative solutions. As such, hydrogen-powered aircraft may well prove to be the wind beneath the wings of sustainable aviation. In conclusion, while it is difficult to say definitively if hydrogen-powered aircraft will dominate the skies of the future, they certainly have the potential to play a significant role in the greener future of aviation. It may take a few decades, significant investment, and substantial innovation, but the wheels are certainly in motion. The race is on to see who can unlock the potential of this promising technology first, and how they will shape the future of flight. Thank you for choosing ReneEnergy.com as your go-to source for all things renewable energy and sustainability. With our YouTube channel, we explore the latest developments and innovations in the field, including hydrogen fuel cells and the use of AI and machine learning to optimize energy consumption. If you're ready to take the next step towards a cleaner, more sustainable future, visit us at ReneEnergy.com and discover the many ways we can help you transition to renewable energy. Thank you for watching and subscribing. Stay up to date on all the latest news and insights by subscribing today.